Hello, my name is Varun and my project is ViralSafe. So first, let's define a problem. COVID-19 has caused the world to be socially distanced for the past year, especially in small spaces. Even more specifically, and more importantly in this case, school bathrooms. I talked with my school's reopening group and they identified school bathrooms as a need where they cannot effectively manage students in there. So what did I do? I created a device using Arduino to help limit the amount of people in the school bathroom. I designed this device first with CAD, and then I built it. And if you didn't know, Arduino is a small microcontroller that limits the amount of people in a room. So let's talk about how it works. A person walks into the bathroom and waves their hand in front of the intake sensor. And this intake sensor is an ultrasonic sensor. Essentially, it emits a sound wave that is too high for us to hear. And then the sound wave will be hit, and then it hits an object, it bounces back. The time the sound wave is out there is then multiplied by the speed of sound, which gives us the distance. And the distance, if it's less than 10 centimeters, which is something I've set, the Arduino moves on to the next step in the if statement. And if it moves on to the next step, it adds number 1 to the variable called num1. And I just called it num1 for a random reason. I don't know why I called it that, but essentially it holds the value for the amount of people in a room. And num1 will then change an LED. So yeah, num1 corresponds to a specific LED. For example, 0 means it's green, 1 means it's blue, 2 means yellow, and red means 3. And these can be adjusted and used an LCD panel instead. When a person leaves, they wave their hand in front of the outtake sensor, and the same process is essentially repeated, but reversed. I also have a system in place, for example, that just makes sure it does not go over 3 or 0 for num1. And this is very important because if it was over or it was a negative people in the room, you can't really have that, right? So that whole system would just break. So that essentially put limits on there and turn specific sensors off. And I built it using CAD originally and then built it in physically. And it's always important to build everything with CAD to make sure everything's laid out. Here's some images. Here's a demo. So here's the quick demo. So when a person walks in, they leave their hand in front of the intake sensor. It's all touchless. And when they leave, they leave their hand in front of the outflow sensor, like that. And it can go as much, as far, and no more now. So let's talk about how it works and difference for version 2. So version 2 is essentially the same as version 1, except it's seamless. The person just walks straight through. And this is better for places where people need to know where they're waving their hand. And it works like this. So there's 2 sensors. This is sensor 1, and think of this as sensor 2. And this is a human. So the human walks in. This sensor is tripped first, so it means they're going in that direction. Other way, this sensor was tripped first. And I also did some battery testing for my prospective clients, which is something they stressed that they needed in the product. And I decided to use a 10,000 milliamp battery pack. In conclusion, my project turned out as expected, with some slight bumps, and all aspects of the device worked. I've learned a ton about this, especially about ultrasonic sensors. In addition, I also have 6 units that are being sold to my school's school, and it's being approved by the school's finance administrator. I'd love to continue working on this, and I already have. I started working on an RFID version. Thank you.